All right, so we're here at the final session for BSO 2022. But just because it's the final session doesn't mean it's going to be a boring session. Quite the opposite. We got a fantastic speaker. Niall is here from IES, our headline sponsor. So I'd like to take another opportunity to thank IES for sponsoring BSO 2022. I think we were just discussing before we all came online that it's been a very, very interactive set of sessions over the last couple of days with lots of fantastic thoughts, ideas, presentations, approaches, and covering the full gamut, from fairly small scale stuff to do with humans and buildings all the way up to urban scale stuff. So I'm very, very delighted that IES was able to come in as a partner in this. And you guys have been a genuine partner because you're going to do this talk, setting out the road for where industry is headed from your perspective over the next maybe 5-10 years. I don't know what sort of time frame you've chosen, Niall, but we hope to see that. To kind of set the stage for where maybe BSO itself might head in its next avatar as it comes along. But also quite deeply because Eric, also from IES, is joining us today because Eric was part of the committee responsible for selecting the best papers from the conference. So Eric will be unveiling with my help towards the latter half of this session, the best paper award. So please, everybody, stick around for that. It's going to be very, very nice. I'm sure everybody who receives the award will be pleased, and those who are here will be curious as to see who it is that's won. So without further ado, I'd like to actually say a little bit more about Niall, because I didn't know that he'd studied at Strathclyde with Joe Clark and Paul Strachan. Joe Clark, as many of you might know, literally wrote the book on building simulation and modeling. And I was just saying to Eric and Niall, we used to sort of carry his, it's a really fat tome. For those of you who haven't seen Joe Clark's book, you should get a hold of it. But make sure your arm strength is well developed, so you're actually able to carry it about. So that's where he's done, I think it was an MSc at Strathclyde, is that correct, Niall? And then, of course, he's been taking on the sustainable engineering roles at various engineering and architecture practices before his current role as head of ISVE sales for UK at IES. So with that, I hand over to you, Niall, to give us your perspective on how you think things are going to shape up in the near future.
Thanks, Sukumar. So I'm just going to share my screen, and then we can get underway. Hopefully you can all see my screen now. Yes, good. And you can hear me. Good. That's thumbs up. All right. Look, first of all, I'd like to thank Sukumar and the wider collective team for holding this event. I'm sure we can all agree it's been both successful and thought-provoking. Going back to the very first presentation with Professor Rajan Rao, I think he encapsulated very well the main point here, that we as residents of this planet Earth face an enormous challenge, and the need for building simulation is only going to increase. I do also agree, actually, Sukumar, you kind of probably stole two of my key points there later on, but we'll get there, and that is about the way that building simulation is moving into operation, and also the need for solutions at scale at the urban level. So really interesting. We'll talk about that a little bit later. But yeah, my name's Niall Gibson. I look after ISV on behalf of IES in the UK. And I've been kindly asked by Sukumar to share a few words today about future trends in building simulation. This is clearly from sort of my own personal view and being within IES. I hope, obviously, I can offer some interesting insights, but I don't think it'll be too much of a surprise to many of you who have been listening to the presentations over the last 2 days. Let's find out. Okay, moving on. So, as Carl Sagan said, you know, to be able to, you need to know the past to understand where you've come from, to understand where you're going to go in the future. So let's look back in time and look how we've arrived here today. We've been designing buildings and thinking about building performance for some time. You could debate at length when building performance first started, but in my personal view, it goes far beyond the image that we see up in this on our screens just now. In fact, I would argue it first started. I would argue that the first building ever built was done so considering some sort of building performance metric at some level. So it might simply have started with protection from for the inhabitants from weather, like rain or wind, or maybe for defense purposes. But either way, building performance and building design, in my view, has always been intrinsically linked from the get-go. For today, though, and in the context of everybody here in this webinar and the BSO, I'm really referencing the introduction of building performance through digitization. It's interesting, the example that we see on the screen here. I don't know exactly when the photo was taken, probably around the 50s or 60s, but this would be a typical design office, pre-digitization, no computation, right? There might have been a single analog machine somewhere in the building, but really all decisions were taken at a human level. High levels of collaboration required, very, very resource heavy. But it worked, right? The buildings were designed and constructed, and there's still, many of them still with us today in use. So that's really positive. Another point to note that's maybe not so positive is what's interesting as well to many people will be clearly we've got a room here full of white males of a certain age wearing basically the same shirts. And it's interesting to me to extrapolate from there to think, well, no wonder buildings from that era all look the same, right? So you get the same room with the same people in there, you get the same outputs. I think that's quite interesting. So digitization, we need computers. So it all started with obviously with the analog computer, but digitization really, as we know, it started really around about the 80s. Something there in the middle of the middle photo. Often, what that meant was you had a single machine with a single dedicated operator. You can just imagine what the reaction was from that room of engineers from the previous slide. These new computer operators would be regarded like rocket scientists, you know, sitting in the corner. But quickly traveling through time, we get to the 90s, and computing had really shifted from that corner of the building to being replacing that draftsman boards and being more generally used within the office. Just some interesting throwaway facts on digitization that I've got here for you. The first fully digital project was from Boeing when they designed the 777 or the 777. That was in 1995. And the stock exchange itself went digital in 1986. What's interesting from these examples that I'm quoting, or these little facts, is that what we start to see is the use of computing power and the deployment of computers it's differently across different engineering sectors. And I'll touch a little bit on that in a little while. Interestingly, here in the 1990s, this is when IES was formed, and for us, obviously it'd be installed in a machine very much like this, that you see on the right-hand side, bringing building performance to basically anyone that wanted it. But in those early days, in the 90s, it probably had an approach much more like what we saw over here with the analog computers, where it was really an individual operator on that machine, that dedicated IES machine, probably regarded as a rocket scientist back in those days as well. And so it began and evolved. So, but anyway, building performance has been around for some time and far from being a new concept. However, the use of building simulation and optimization techniques today we're in a very interesting time. We face huge challenges with the warming of the planet and the consequence that has all around the world with more extreme and erratic weather events. Ultimately, the longevity of the planet itself. And as we've heard over the last 2 days, building simulation absolutely has a key role to play in mitigating this. So let's move on to what's today. Let's see where we are. Of course, as you might imagine, I'm a huge fan of the ISBE and what we do at IES, and I hope everybody here listening is as well. Don't worry if not. But the truth is, we're not the only ones. There has been endless effort into reinventing the wheel, creating tools which are very similar, answering similar questions. But the real challenge is pushing the capabilities of what's possible. And we can pick up on this in the future trends section in a little while. What's also interesting is that while this looks like a lot of tools, this is just a snapshot of what has made it. There has been millions of hours of development put into these tools and trying to tackle accurate prediction of how a building's design, how is it actually going to play out in operation. And there's been many tools which haven't made it and haven't made it on this list, but just a snapshot. So just to see if everybody's listening, here's a little brain teaser for you. It's a bit of a rhetorical question, so don't fill the chat box if you don't need to, although you can do if you want. But I wonder if you know which tool is the most used. And I'll give you a few seconds to kind of think about that. So have a guess. Which tool do you think is most widely used in our industry? Yeah, it's Excel. Okay, and I'm sure that's the same anywhere in the world. And it's really interesting, and I want to sort of draw out in this point as there's issues with this, and I want to sort of talk about this. So the first thing is my own personal experience. Obviously, my focus is on the UK, so apologies to the international side of things. But in the UK, I often I'm meeting with design teams and all levels of practice and buildings, and they're often saying, "Well, I'm doing I'm using Excel to run heating and cooling loads, so using Excel spreadsheets." From a BSO perspective, this is frustrating. Like, yes, that's an easy and quick route. You just fill in the room areas and boom, you get an answer out. But the question is, like, what value does that actually have? Over the past 2 days, we've heard how building simulation can be used like a surgical knife to solve the issues today and tomorrow in detail. We're definitely at a point where that sledgehammer approach, we're just way beyond that now. So there's a real issue there that I would say highlighting is education. And teasing on that, there is an issue about accessibility and education. We are seeing building performance growing we're seeing it grow across new sectors and disciplines. No longer is it just the domain of the engineer, but we're seeing architects, contractors, local government, sustainability consultants, and many others. This is great. However, there is a trend where we're seeing people trying to shortcut to the output, right? So they're saying, right, okay, so is my building going to overheat? Is my building going to meet local code compliance? But there's an issue of them understanding the methodology and how to use the tools properly to get there, right? So in the UK, for example, we're actually, one of the issues we have in the UK is that we're very code compliant with our building regulations drive or influence our building design maybe far more than it should. Speak about that later as well. But we have an approach where we have tools for compliance, and but these tools were they were never designed to be performance prediction tools. They're just there for compliance. You know, is the building compliant with building regulations, with building codes? That's not the same as saying this building will perform like this. Okay, so this is where the performance gap comes from, and it's the same with the likes of Passive House as well, where you know it's a methodology, and they have a compliance a spreadsheet that you undertake, but it was never deemed to be a performance prediction tool. But we have an issue where the understanding in the industry, the education there isn't as robust as it now needs to be, as things are moving on, techniques and technology are moving on, and there are issues where we're using the wrong tool. So Excel is an issue. We need to be moving on to that thing about the right tools for the job, for lots of reasons. It's not just about accurately predicting the outcome, but there's liability there. So what we're seeing as well is a big shift now in the industry where there is financial risk associated with these calculations. So it's not a theoretical calculation that has no impact. As in, well, that's what we did at design, and the building's operating the way it is. We have a performance gap, so therefore, what does that matter? Right? We just accept that. We're no longer accepting that. For example, where I am just now, so I'm based in Scotland, and Scotland, while being in the UK, has a devolved approach to building regulations and funding, and we've got a really interesting example where the Scottish government will fund highly sustainable buildings, public buildings, so like schools, for example. So they will give money to local authorities to build these low or net zero buildings. But the rule they have is that the building has to meet a certain benchmark. I think it's something like 64 watts per meter squared, something like that. And what they'll do is, if the building is that benchmark low, they will fund 50% of that building. So that school that might cost £30 million to that local authority, half of that, 15 million, will be provided by the government, as long as that building in operation proves to be that. But if it is above that benchmark by any margin, the Scottish government will ask for that funding back. All right. So this is where using the right tools, using the right methodology is absolutely critical. Where is that local authority going to find £15 million if the building in operation doesn't perform as it was intended to? Is it going to be the local authority that pays that? Is it the contractor? Is it the consultant? Is it the engineer that did the analysis and came up with that answer? Really interesting things. What else is going on? Okay, so I do like this slide. I'm sure we've all seen this slide in some form, maybe over the years, but it's always a bit of a humble slide to share within the industry. In the built environment, we get very excited by data. Certainly in the world that I am in and that IES is in, the whole idea of full energy models, which can be used to predict how the building's going to perform in operation with a high degree of accuracy. And then once the building's built, being able to bring operational data and create a calibrated twin, a calibrated digital twin. But we think this is really exciting and leading, and it is. But compared to other engineering-based sectors, we are much further down the list than maybe we first think we are. Just look at other engineering sectors like ICT, finance. We think about aerospace, Formula One. They deal with the feedback of real data all the time. They just couldn't imagine operating without it, and they've been doing that for years, decades. Well, maybe just they've really advanced. So we are on a journey. There's no doubt about it. We are, and it's fast paced, and we've got lots to learn. Not just from within ourselves, but with our colleagues in other engineering-based sectors and what they're doing and the techniques that they're doing. So really interesting time there. So that's where we are. So what's the focus going forward? Certainly over the last couple of days, this has been mentioned quite thoroughly, but really our whole main effort now is net zero. There's lots of variations on this, but ultimately net zero is the key focus. That's the main effort. For us, that really splits into two categories. The first one being new buildings. So using techniques, using building simulation to make sure that they are net zero, operating at net zero at day one. And that's a fairly mature thing. But the big challenge is looking at our existing building environment, the many hundreds of thousands of buildings all around the world that require decarbonisation, and that's going to have to happen at scale. And of course the big challenge is in quick time, right? We're kind of out of time. That's the thing. So big challenges there, but at the same time, we cannot forget about other building performance metrics, right? So while we're very focused on carbon and energy, we also need to maintain quality and health and well-being. We need commercial viability, so value, capex, operating costs, all of that. And so all of that together is where building simulation sits, right? That's what makes that happen. So how are we going to do that? Well, I've got some great news. We don't need to worry about decarbonisation anymore or energy efficiency. Nuclear fusion is here. And so that's the end of my slides. I'm only joking. So we're at least 20, 30 years away from this having any real impact in terms of unlimited clean energy supply. Amazing if that could happen sooner, but it's not. So we're back to simulation, right? We're back to what we've been talking about over the last 2 days. We need to look at how we deal with energy resilience through demand and supply, and that's where it falls back to building simulation. So I've really got I've got two key points I want to talk about in terms of the future and where it's going. And we've been talking about this over the last 2 days. So the first one is on single buildings, and it's about that journey going from design into operation. And what we're really talking about here is something that what we call calibrated digital twins. Now, digital twins is it's interesting because I guess many of us might be saying, well, we've been doing digital twins for some time, right? And you'd be right. I do think, well, what is a digital twin but a virtual representation of that building in question, that project, that design. But when we talk about calibrated digital twins at IES, we're thinking about a virtual representation of that building, but in terms of its building performance. right? That's what we're talking about. So you can log in, you can take your laptop from anywhere in the world. I could be sitting in Sydney with my laptop open, and I'm able to understand exactly how a building is operating in London or anywhere else in the world, and be able to start to do analysis on that and feedback and improve that building. That's the next step. But again, there's a theme here about education. Are we ready for this as an industry? So again, in the UK, we have we have an interesting thing that's happened where we've been very code compliant, as I've been talking about, and so actually our skill base of engineers that do building simulation, they're not used to doing full energy models. Not like if you go to the States or Scandinavia or in other parts of the world where doing ASHRAE 90.1 PRM models are kind of second nature. Those full energy models, that's not the case. That's not been the case in the UK. However, over the last 5 years, the UK has been closing that gap and undergoing a lot of upskilling there to do that, and that's driven by the need for full energy models to close that performance gap, to increase the accuracy of prediction of how the building's going to operate in operation or perform in operation. It's been driven as well by the likes of neighbours. I don't know if that's something you know about, but where there's a requirement at design stage to follow a methodology called Design for Performance. It's very similar to CIBSE's TM54, where again, it's full energy models, but that's great. And so what we have now is the ability, so we've got the technology for this, and we've now got the skill for it. And what we need to do now is take that full energy model at design, and once the building's operating, bring that operational data from that building in there to create that calibrated twin. So that you're removing any assumption, and it's a true representation of how that building is going forward. So that's one of the big trends that we're seeing and we're working with. The great thing about this as well is that for those existing buildings, the people that are best placed to improve the performance of those buildings are the very people that are designing those buildings as well. So that skill set, a bit like Liam Neeson, that unique skill set that they have carries right the way through from designing into operation, and they're best placed to continually improve that building stock going forward. That said, in the design stage, we as everybody knows here, that we are dealing with a skills shortage. There's just not enough experienced, qualified engineers, and that demand is obviously only going to increase based on this trend. I was really interested yesterday, the discussion yesterday about the very fact that do we have enough literate modelers? I thought that was a really interesting topic today. And the truth is, we have many modelers, but they're all actually, their capabilities are very diverse, but they would all probably identify themselves as being simulation experts. But what does that mean, right? So again, education. So that's the first big trend, is moving from design and into operation. And I guess there I was talking about single buildings. The next big challenge, as I said, is about looking at decarbonisation of our existing building stock at scale. So we've got a choice to make, and that choice is, do we do simple analysis at scale, or do we continue with detailed analysis on each building? Well, the answer is, we believe, to be both, and that's driven, and that's really driven by time. We just don't have time. We need to tackle and decarbonise as quickly as possible. So we have a very mature understanding of how to follow that process from a design into operation on a single building. But what we need to do is have the technology to look at buildings at scale, And what I mean by that, it could be a university estate, or it could be right the way up to smart cities. Lots and lots of buildings there. And that's what we do, right? So obviously, what maybe I should mention or not, but I will mention at the end, is obviously IES have the technology to do this, but yeah, it's a combination of all of this. So those are the two big trends. Just a little bit about what this actually looks like in reality. So first of all, when we're looking at single buildings and doing calibrated digital twins, we at IES we have a tool called Scan, and effectively what you're doing there is just you're taking that full energy model that you did at design stage. You're able to bring your BMS data from any other sensor. It doesn't need to be just the BMS. I often hear people talking about, oh, do you connect to BMS? But anything that's offering up time series data, it could be weather data as well. You bring that in, and you basically replace that assumed data and profiles with real building data. There's a calibration, obviously you follow a calibration technique sort of laid out by, IPMVP, etc. And we've got tools there that automate that process for you. So you end up with this calibrated digital twin. And you do have a proper virtual view of that building performance, right? It's really interesting. And the key thing here is like buildings, there's lots of things happening in this. It's a really interesting thing, but buildings have, it used to be 10 years ago, buildings didn't have any data. Now buildings have got maybe too much data. And so the trick is actually, you need to be able to mine that data and then have that data put into sensible form. That's the big challenges for these things. I see lots of platforms and apps that display data, but they're just displaying data, right? That's what good is that? What you need to do is present that data in a way that allows an experienced, qualified, educated engineer to be able to understand, translate that data into building performance so they can look for improvement. What's going wrong? How do we fix it? What can we improve? And that's the whole purpose of why you would even bother with a calibrated digital twin at that stage. So talking about on the other side, looking at buildings and scale, I just thought I'd share this now, just for the purposes of today's presentation. It's just a very simple slide, but actually it's actually a dynamic dashboard. There's lots going on there. I can show you another time possibly, but this is a project, Irish Life in Dublin, and what we were looking to do here in this project, or what we did was we looked at 4 existing buildings and looking at creating a roadmap for decarbonisation for those 4 buildings, right? So what we had was, and one of the reasons these 4 buildings were picked is because they had sleeping digital twins, right? So what's a sleeping digital twin? A sleeping digital twin is basically where there might already be an ISV model at the design stage, but has just been archived somewhere, right? Because there was never the thought or the intention to do anything more than that, for example, in the operational stage. So we were able to retrieve the virtual environment ISV models from design stage, the sleeping digital twins. We were then able to follow the calibrated modeling process that I talked about in the last slide. And that gave us then the baseline buildings for each one of these. And if I had the app open, I would be able to click between all of these things, And then the next thing is just like what you do just now at the design stage, is you're able to look at where can the improvements be made, right? And you're able to do that through whatever parametric and optimization techniques you want to do, but essentially you're looking to optimize what the best mix of improvements are for that building to try and get that to net zero. And then what we're looking at here is the decarbonisation pathway, which is dynamic and tied to those ISV models. So as these buildings go along its journey in real life, right, real buildings, they are linked to this roadmap. And this roadmap will change as these improvements are carried out on the building. It'll take into account of a grid decarbonisation, and basically you're able to see that downward trend of and that journey towards net zero. And so we have that. But a really interesting point here is, and this is something that we're talking all the time at IES, is it's not just, we can't just limit ourselves to highly qualified and experienced building simulation engineers. The net zero carbon agenda applies to everybody, and everybody has a stake in this. And so when we create these tools, they need to be communicating effectively across lots of different levels. So even Joe Blogg walking in off the street, walking into a reception area, they might see, for this particular business, for example, they might see this up on a screen, and they'll be very, without any prior knowledge, be able to look at this and understand that this business is has a net zero agenda, and that they are working towards their buildings going towards that, right? But it's all being fueled by the same data. It's the same data that highly skilled engineers are operating with, but we're able to communicate from that data at different levels, and that's an absolutely vital challenge as well that we have. I'm just coming towards really the last couple of slides here, so stay with me, please. So just to kind of recap where we see the journey going. It's going to become ever more complex. The challenges that we have today, the challenges that we had 20 years ago, we thought were very complex, and they're just getting more complex. So what we're having to do with digital technology, we have to do more, and there has to be more brain power basically going into it. Design, that true link between design into operation through the calibrated digital twins, that's absolutely key to this. Basically, the idea of the performance gap that we used to talk about, that really doesn't exist anymore. It really is just that direct link there. And we need to look at existing building stock at scale quickly. One of the key things I hope that maybe you got over the last 20 minutes or so is about education. Now, education is something we think about at IES a lot, and it absolutely starts at tertiary, maybe even before, right? But we basically, the common thread here is that graduates going into the workplace need to be competent in being able to support answering these questions when they go into industry, right? So whether it's understanding the technology and doing that, but it's the fundamentals. They need to understand the building physics that goes behind all of this, for sure. And it doesn't just stop at that point. It has to continue into the industry itself. Going back to that point about Excel, we need to be able to, as professionals, continually develop and do this to help push the advancement that we need. That raising that that league of where we are in the engineering sectors, we really should be pushing that right the way up as well. And I suppose finally, just going back to that slide that we started with the white men of a certain age wearing the white shirts in that design office, that absolutely isn't an industry that I recognise. What I see is a much more inclusive industry, and I suspect probably that's why it's a really interesting time to be in construction, and the output, the buildings that we are creating, and the innovation that's happening within the industry is unparalleled. I really enjoy that. So that's good. Final slide, if I may. So hopefully I've tried to be quite generic, not too IES. So this is just, I'm going to cover IES in 60 seconds because my last sort of takeaway message really to you, knowing your background and what you do, is that IES is totally committed to education and the academic sector. And in fact, Eric, Dr. Eric Roberts, who's my colleague, who will be looking at the awards next, just after this, he leads on the academic sector. But all of this technology that we've talked about to do with calibrated digital twins, so buildings in operation, and looking at decarbonisation of buildings, looking at energy networks, the bits in between, all of that is available, right? So we have that technology. We've been we obviously have been supplying that to the industry, for at least 5 years, for example, on that side of things. And we work with a number of universities, both on research, but more importantly on the teaching side. And so I would say, if you are interested at all at any of this, then please do get in touch with myself and Eric, and we're happy to share this with you and to help you on particularly on the teaching and research side of that. But just to give you a quick quiz on this, our last sort of 60 seconds. So you know about IESVE. Obviously that's well known, using the Apache engine. That's the simulation tool at the design stage on new buildings and existing building stock. That's there. You might not know though, but you should do, is SCAN. And SCAN, it complements the virtual environment, and that is looking at bringing operational data from buildings in operation in. It uses clever techniques for mining the data, making sense of the data, and basically getting you to the point of very quickly to the point of being able to just apply analytics to understand what's going on in that building and where to find improvements. And you can do that for single buildings and multiple buildings. We've got the virtual networks that is looking at the bits in between the buildings, so we can't forget about that. We cannot be limited anymore by buildings themselves. When we think about a university campus, there is opportunity there for the entire estate to go to net zero and to be decarbonised, not just individual buildings. And so we need to look at energy networks, district heating and cooling, water networks. We need to be thinking about electric vehicles. We need to think about renewable energy centres and bringing that all together. That's what virtual networks for. We need to be looking at buildings at scale, right? Quickly assessing and looking for quick wins for decarbonisation and tracking that progress. That's what ICD is for. And then tying this all together is what we call our collaboration cloud. And these are highly tailored dashboard type apps. So taking the data from all of these tools and being able to present them in any way that you want to effectively communicate to whichever level of stakeholder that you're dealing with. Really interesting. So whether it's just simple communication to residents or occupants, to dynamic maintenance dashboards to allow for the energy teams to react quickly or to be proactive about the systems in that building, to metrics on ESG for clients. There's a whole range of dashboards there, and our user base, our clients, are able to tailor all of that as well and bring that together. But that final slide brings me to a close. So I just want to say thank you very much for listening. I hope my my presentation wasn't too much of a ramble, and it sort of drew out some interesting points. But I do believe that what I've listened to over the last 2 days was touching on most of this, and so I don't think Sukumar. There's too much of a diversion in what basically we're thinking about compared to everyone else, which is great, right? It kind of gives me a bit of confidence that we're on the right track. So yeah, I'm happy to. I don't know how we're doing in time, but I'm happy to take questions. Or maybe we should do the awards and then do questions. I'm happy to do whatever you'd like.
Thank you. Well, firstly, Neil, I've got to apologise to you. I've been calling you Niall all this while, and for somebody who's got a pronouncer on the end of his email signature, I should have done better. So I've corrected myself instantly, and I shall henceforth make we're learning interesting things all the time. So thank you, Neil, for this very, very interesting and wide-ranging presentation. I love the fact that you started with Carl Sagan, one of my personal favorites. I happened upon a YouTube video of Carl Sagan a few weeks ago, and I realized he'd summarized my entire lecture, 2-hour lecture on climate change in about 12 minutes in a presentation to the I think it was to the Senate. The Senate had a climate change committee in the 1980s, the US Senate. So thank you for starting with Carl Sagan. And also thank you for starting with that picture of all these drafting tables. I'm not shy to confess that I started my career as an architect on a drafting table, much like that, and probably as a result broke my back forever. But the other remarkable thing about that picture is, apart from the homogeneity of the tables and the people in it, was actually the fact that it's such a deep plan building, and there wasn't there was in that whole picture it was just a bank of artificial light on the ceiling, and it was remarkable that was considered to be the norm and actually a sign of a good work environment. I've been taking notes as we go, so I'm just trying to bring people's memories in, because there haven't been any questions so far, which is quite interesting. There are a lot of people in the audience, but somehow questions for this particular session, I think people are still digesting. So hopefully what I'm saying will prompt thoughts from the audience. I think Excel, you talked about Excel for quite a long time, which is quite interesting, because we use IES, we use things like Design Builder and Energy Plus when we're trying to do any kind of programmatic work. But then Excel, we've actually developed many tools in the last 5 to 7 years, trying to leverage the power of Excel, which is really quite an interesting thing that you've picked up on it in a way, and the fact that simple tools. The simple but flexible tools, I think, do have a continued place in thing. I had a sort of comment on which I don't know if you had any thoughts. You talked about compliance, and this performance gap issue in relation to code compliance, and in work we've done with Passive House. I published a paper on Passive House homes in the UK. It was the largest study. I don't know if anybody's done a larger one by now, but it was about 100 buildings spread across the UK. And what we did was we worked out what the design target was from PHPP, which is their spreadsheet-based compliance tool, and then measured performance between the first and second year of operation. And usually the first year of operation of any building is usually the worst year of operation of that building. But what we found was quite surprising, and I guess surprising in some ways, but from a sort of traditional hat on, but unsurprising in other ways, which was that the mean heating energy demand for that entire set of dwellings was below the predicted mean target for that entire set of buildings. And there's something in a way, because PHPP being spreadsheet driven, I think there's something we actually don't know what it is that results in this. But another aspect is actually linked to what you're saying, tangentially somewhat, I would say, to the digital twins business, because the whole point about digital twins is this sort of making sure that what you've actually put together on site is something you can measure and understand to be true. And then actually you can go back and reflect saying, oh, what did we miss in the model? And why doesn't the model maybe match reality? But this is something that's a little bit programmed into the PHP, into the passive house process through this sort of compliance regime that actually goes and tests, hang on a minute, does this building, can we do a depressurization test in addition to a pressurization test and things like that, to actually see whether things are the way they are meant to be. So I'll pause my thoughts there just to get some if you're up for it.
Yeah, of course I am. Of course I am. So, the thing with Excel to start with is it's accessible. So everybody has some level of expertise in Excel, right? So it's very accessible. I think really my main point though is about using the right tools in the right way. And Passive House is great, but there is a skewing of its true intention and its true capabilities, and this is what we've got to be careful of. Is that I think what we see is Passive House ultimately is a methodology and an approach to construction, low energy construction, right? And it's great. So if I was building a house, I would definitely be following Passive House for that. But what it definitely can't do is be used as a design tool to get you to a net zero carbon building. It can't do that. It's just not within its capabilities. It ultimately was never designed to be a performance prediction tool. But what you have with Passive House, particularly in the architectural sector, and local authorities, a big one as well, is they have the concept is relatively clear to understand, and they kind of hold on to it. But ultimately, you can't. It's not right. That can't replace building physics. And building physics, you can't change the physics. It ultimately comes through building simulation, and you cannot. There's a reason why, whether it's the virtual environment design builder, TAS, ESPR, you still have to. The building physics are all the same in these platforms. You still have to input the same data in these platforms. You can't short circuit that. I think that was my kind of main sort of point there, and so that's where Passive House is more of a methodology on that side. I think though, just one final point on that side as well is that when it comes to residential, residential is it's very tricky to try and predict the performance of residential, right? So you could have a street where you build 10 houses, but each of those 10 houses, while they could be identical in terms of design and orientation and weather impacts and all the rest of it, but you could have one house that has a family of 8 and another with one occupant in it, and that would completely change the ultimate performance of that building and what's actually going on there, right? So how do you predict that? How can you predict who's going to be using that building? And so I think that, and with assumptions, Passive House definitely has a clear role to play, and I see some really encouraging results in there, but it still can't get you to net zero. That's the point. When you start moving to more complex buildings like education buildings, schools or hospitals, yes, you can use the principles of Passive House in there, but there is no room, I would say, to risk basing everything just on the Passive House spreadsheet. You absolutely need to be using the principles of building simulation, full energy modeling. That means ASHRAE 90.1. That means TM54. Like you have to do that, and particularly that example of what I spoke about in Scotland, where there are millions of pounds at risk based on performance. And this is what we're seeing. We're seeing this energy performance contract written into these contracts, and this is what's really interesting. It makes what we do here in building simulation tangible in the real life, right? It has meaning. There is obvious rewards for low energy design, but there's real liability as well if you get it wrong, and that's the way it should be, because there's too much at stake.
Yeah, I couldn't agree more. Actually, I mean, your example of the sort of Scottish situation was news to me. Actually, I didn't know they had this wonderful stick to beat people with and get them to comply. So that was very interesting. And the challenges you picked up, I think, in terms of new build net zero, and I think it came across yesterday in the debate as well, didn't it? I mean, how compliance regimes can actually militate against achieving net zero targets because of the way they've been put together, and the continuing challenge of existing the existing built stock, which will, we know that roughly 80% of the buildings in 2050 in the UK have already been built. So it's a serious challenge. Not so much for the global south. That's one of the reasons we really think some of these ideas need to be picked up and embedded with tools that enable rapid and meaningful analysis, and to educate people. I think you talked about education towards the end of your talk, and it's critical because there is an opportunity there. Because if the global south is going to double, say, the global built floor space in the next 30 years, we are walking into another disaster. If somebody was talking, I think it was Jacques was talking about how, we are already 1.1 Celsius above the historic global surface temperature average. And 1.5 as a target, to me, seems completely unattainable. I'll be honest with this audience. I don't believe for a second that humanity has shown any sort of capacity to date to limit temperatures to a 1.5 Celsius rise. So I think 2 Celsius is virtually guaranteed. And there isn't any at the moment. I'm sorry if I'm sounding cynical, but at the moment I don't see any reason to be hopeful of even 2 Celsius. There's a good chance we might even exceed that. So actually, that thought ties into sort of the thought that was emerging towards the end of your talk for me, which is to do with complexity. You talked about just how complex the industry and the business has got in the last 20 years. And one of the reasons for the complexity is that the targets are shifting, the ground is shifting beneath our feet as we are doing this. More data is becoming evident. The impacts of early climate change are now evident. And so you're constantly thinking about, well, should I spend more efforts mitigating the impact, or actually should I be now planning for adaptation? But actually you've got to do everything. So, all of this adds a huge amount of complexity. And I like this focus on digital twins because I think having a sort of feedback to your digital twin that, as you said, with more meaningful data, because I think we are now in a sort of situation, certainly in the global north and actually even in the global south, where data is becoming cheap. But the problem is, how do you turn that into meaningful information? We've tried to do some research on this. But actually having that feedback between reality and virtual version of the building would be quite important in moving buildings into performing as they should and as they would if you had actually taken certain design decisions or alterations or such like. So Henry has a question. So I was hoping this would happen, that you and I would speak and that someone would be prompted. So Henry, thank you very much. Henry thanks you for your presentation, Niall. He says, you alluded to the role of the education sector. Are there perhaps any specific initiatives by IES to support mastery of these topics and tools by architecture students, especially in the global south?
Yes, yes, absolutely. So education is something that we it's at the very core of what we do, and I'll explain this very quickly. I mean, our whole business came out of, it was a spin out from university. It was Don McLean, who owns IES, still owns it. This was his next step after his PhD at Strathclyde at Esri. Okay, so this is where IES came from, and I can quite honestly tell you without any doubt that the academic side that we work with, whether it's through joint research projects or whether it's helping with teaching, is a key thing that we do, regardless of where you are on the planet. So what can we do? So we offer the technology. So basically, all of the technology that you see here, it's all obviously commercially available. Okay, but in terms of the academic space, we support you with that technology. So we give you the technology. We've got training capabilities as well that's kind of online that we can give to you. So you effectively, what typically happens in the UK is that the lecturers that are doing the training, for example, to the undergrads, they can choose to either do it themselves in their own way, or they can use our online training. But we fully support all of that. And we Eric and I spend time traveling around universities, lecturing, all that kind of stuff as well. So we can, but that's maybe not so accessible outside the UK. But yeah, there's lots of different ways. So if that was Henry, if that's of interest to you, then just drop me an email there, or anybody can drop me an email, and I'm happy to do that. One interesting point that I should say, I mean, when we're talking about just separate, actually, just picking up on something you were saying there, but I absolutely agree what you said about data and data analytics. I mean, this is where, when we think about building simulation and what we're talking about, we're experts at building data and the analytics that go in there. And you see these apps and they give you data and you think, I can't do anything with that, right? It's crazy. And that's kind of what we do. But one point for you, to give you an idea of what we've been doing at urban level. So using our Apache engine for energy and solar analysis at urban scale, we've had a project where we've had over 90,000 buildings assessed there, and that's the kind of scale that we've been working at numerous projects. So there's lots going on. So if the urban side, and I know that's been picked up a couple of times over the last today as well, then you just, if you go on our website, there's we publish everything, and it's interesting. But yeah, but yeah, on the training side, get in touch. Happy to.
That's brilliant. Yeah, I mean, on just very, very briefly, I know we're running out of time. People are getting very tired, but I just want to say, I mean, making data more meaningful is absolutely critical, because it affects everything in the chain of information, right from the client to the designer to the site manager. If the information is not properly expressed, you get people misunderstanding things. I was just watching a documentary on, I think it was the Mars rover, and one of the previous missions failed because someone had forgotten to convert from imperial to metric. It's, if you're not careful, that's $1 billion blown up in smoke because they set the wrong numbers. Nick has this comment on growing availability of data in the global south. What is the challenge integrating rapidly changing built environment data into modeling approaches in a meaningful way? Thinking here of both the planned development in the global south that will occur in the future, but also the informal development that affects buildings and urban performance, may not be as readily tracked. Oh, big question, Nick.
Yeah, that's a big question. Well, I think, first of all, the key thing from a technology point of view, so from Brussels about it, is that we have to be able to be relatively agnostic. So we have to look at data in all forms. So we actually have, so going back to, if I can go back to this slide here. So this tool Scan, I know obviously this is a kind of very simple diagram of what goes on, but we have what we call it is our Scan robot this is an internal language, but it lets us look at data in all shapes and forms. So we're totally agnostic. It's nothing to do with particular manufacturers or brands. As long as it's time series data, basically we can make sense of that. That's the thing. So what's the value of that, and when did that happen, and then we can make use of that. So that's the first thing. So really, any data in any form can be brought in. There was the second half there. What was the second of the question about the global south?
Yeah, I think Nick was pointing out the fact that I think, as Jacques and Anna pointed out earlier this morning, that the problem in the global south is this sort of huge disconnect between formal and informally built sort of settlements and buildings and cities, where you've got a lot of people. Jacques estimated that something like a quarter of all South Africans, for example, don't live in formally built environments. So Nick's asking about, well, what can we do? I think, if this is the intent of Nick's question, Nick, correct me if I'm wrong, what can we do with data maybe to make it more meaningful, to actually help tackle even things that are not in the sort of the domain that you've presented so far, which is, well planned, properly organized, ordered situations.
Yeah, and I think this is happening. So our understanding of building simulation and the building performance metrics that we do, we're constantly adding to it. So so the minute you start looking at particularly urban level and population, smart cities, we've been involved in a number of these, you start to look at things that are not second nature to probably what we would deem to be core building simulation. So you start to look at I don't know, but when you're going to, trying to think of a wee thing here, but when we're looking at the virtual networks, for example, so suddenly as a building simulation engineer, you're starting to look at energy networks. Okay, so that's not something that would be maybe within the core skill set. Just as there's a big thing about ESG, and so we're starting to look at social and governance and starting to talk that language as well, and there's crossover. But as building physics engineers, again, that's not something that's second nature to us. So yeah, if we were looking at South Africa and we're looking at townships and how do we model that? That's something that we have to do. That you cannot skip around that element. You have to be looking at everything as a whole. We've learned a lot as a business through our smart city joint projects, where we've been working with Transport for London, for example, and we're able to model with that people movement, egress, but a lot of the from my sort of humble understandings, a lot of the principles of where you might look at like fire evacuation or egress in a building, it can translate quite well into the external as well. And so you're kind of joining up these dots as best as you can. But we're involved with that's what we're doing. So within our urban tool, like saying we're looking at areas of over 90,000 buildings at once. We're not just looking at the buildings, we're looking at the bits in between buildings, right? So we're looking at transport nodes, proximity to amenities, types of buildings, diversification of where people are moving and what's going on. There's all sorts of new performance metrics that are introduced when you start to look at multiple buildings. Yeah, so that is definitely one of the that's a really interesting question. That's definitely one of the a key area for the future, that's for sure.
Can I add something to this, actually? I mean, one of the things, Nick, is that sort of two challenges in the Global South. One is data itself. And although I said data is becoming cheap, but it is often also cheap data in the sense that it often doesn't lack the fidelity and quality of data that you might easily generate in the global north. For example, Paul's presentation earlier today talking about the differences between their photogrammetric approach in Ahmedabad as part of that Indo-UK project versus the kind of LiDAR-based data that they're used to, obtaining, say, working in London. Now, so there is a sort of quality of data issue. So access is improving, quantity is improving, but the qualities are not the same. They're actually quite different levels. But what there are now is opportunities using, translation techniques to convert and extract the meaningful information from even poor quality data to actually turn it into something meaningful, which is what Niall has been talking about. How do you convert data into something meaningful? As a very concrete example, there's a spreadsheet-based sort of simple early-stage design tool that David Coley and I have been working on. It's called Zebra, and it comes packed with about 3,000 weather files worth of information, so you can actually take it to different parts of the world. But you quickly realize that the moment you want to put a building on a particular site, you're suddenly stuck, because once again, the weather file could be 300 kilometers away, as I demonstrated earlier this morning. So one of the things I wrote was a little translator. So if you happen to have the weather data, the translator will then eat up that weather data and convert it into something meaningful that the model can understand. So we need systems that allow interoperability, that allow new data sources to be pulled in. And you've talked about this, Niall, as well, in the I think it was in the 1 or 2 slides before this, where you said, well, actually, it doesn't have to be BEMS data, it could be IoT data. So I think that is where the challenge in the global south has got to be the conversion of maybe easier now to obtain data, but not necessarily data that's always reliable or at the same scale, or that is maybe dirty in some ways. I mean, it's not just necessarily true of the global south, it happens here as well, but the challenges at scale are different. So I think that's one of the things I thought I would mention in relation to Nick's question. Lovely, thanks, Nick. I think we've successfully overrun by a huge amount of time. So I think people are waiting to hear what the outcomes are. So if you would like to stop sharing, and we can have Eric come on board. Excellent, Eric. I think I can share my screen here. There we go. So thank you, everybody, for your enormous patience while you're waiting for these award announcements, but I hope you've enjoyed the presentation and the discussion. I was going to summarize the last 2 days, but I think maybe I will send an email summary rather than keeping you all waiting here. I think we've had opportunities to briefly reflect on all the goings on over the last 2 days anyway, so hopefully I'm not missing very much by not formally summarizing the proceedings. So we'd like to move into the Best Paper Awards immediately. And if Eric, would you actually like to just take over, and I'll just be your robot and I'll press the buttons. How about that?
Thanks, Sukumar. Hello, everybody. Well, first of all, I'd just like to thank everybody for the last 2 days. It's been very informative, very different from myself. Very good set of papers, good discussions. Very much enjoyed it, and I hope to see this format again in the future. So well done to everyone in putting this on, especially well done to everyone that's contributed. Well, thanks to everyone who's submitted papers. Huge amount of papers, considerable effort from everyone, really good. Unfortunately, myself and Professor Coley had the unenviable task of actually trying to pick some winners from the best papers. It's not a difficult task itself. And, who am I to judge anyone, I always think, but unfortunately that was given to us to do. So I think we'd like to just start off with the best paper. So the best paper itself, this paper showed that simulation can be used to aid in improving the living standards of some of the most important insects, the bees. So I'm not going to jump into the wicker man here, but it does take a unique take on how we use our learnings from decades of work done in the field of human-centric building simulation, and how we can apply it to enhance other environments and also push the envelope of simulation. So from that, I'd like to extend our congratulations to Derek Mulville Mitchell from Leeds University for the best paper of the BSO Conference 2022.
Brilliant, thank you. I think Derek isn't actually here unless he's anonymously attending. I don't think he is. So we will communicate our decision to Derek by email. Thank you very much, Eric. Shall we move on to the next one?
Yep.
Oh, that's that's the certificate for Derek. Okay, next one.
So our second prize is for the best special focus paper. Now, this paper eloquently conveyed how building codes can be adopted across the global south, and they very highly visually convey the adoption of these building codes within that area. Very easy for people to access and understand what's going on. But it also highlights to ourselves what the true extent of the task ahead within these areas lie, the process in these developing energy code markets. And they really show us where there'll be huge amounts of ongoing and upcoming developments that will simply fall outside of any code compliance. And they probably never will they benefit from through augmentation, through the use of any simulation modeling, and then in the end, leaving us with greater problems of decarbonisation. So with that, I'd like to give congratulations to, sorry, I'm going to butcher your name now, I think Tarine, Henry and Jacques on their paper, and using system dynamics frameworks to develop a decision-making model for building energy codes in the global south. So congratulations to you all, and thank you very much for providing a very, very informative paper.
Well done, Tarine. I think you're on mute.
There we go. Thank you so much, Sukumar, and for hosting this conference. And obviously, I don't know where my colleagues are. I can't see anyone. But a special thanks to Henry Igugu and Prof. Loubser, who is our mentor in leading us to be able to do such wonderful work and hopefully assist in this fight towards climate change, and especially in the global south. And thank you for making this platform available to the Global South participants.
That's wonderful to hear. Thank you very much, Tarine. It was a delight. And yeah, thank you to everybody who submitted a paper. As Eric noted, I think it was a tough choice, and it was tough for us as organizers because we actually shipped over quite a lot of papers to the committee saying it could be any one of these. Would you please try and pick two? So I think they had a tough task, but I'm delighted with the two papers that have been selected. And I have to say, we had nothing to do with the selection whatsoever. It was entirely Eric and David. So thank you for taking the time, Eric and David, for picking the papers. And thank you, Tarine, for producing this work. And of course, thank you, Derek, who's not here, for producing a very, very interesting paper as well. So I think with that, we come to the end of the proceedings for BSO 2022. And it just remains for me to thank Niall, Eric, Tarine, all the attendees. Thank you very, very much. And everybody who helped. And luckily, I've made a note of everybody who's helping right at the beginning, knowing that there's always conference fatigue towards the end of the 2 days. So thank you, everybody, for a fantastic time and for your thoughts, ideas, and presentations.
Great, thank you.
Bye.
Thank you all.
Well done. All right.